Welcome back, folks. In today's class, I'll talk about the new chapter that is electric field. Electric field. Now, in the last class, we were talking about the force. So force formula for the electrostatic force, it was Fe, and this is the absolute value, which is equal to KQ1 Q2 divided by R square. That's what we've learned in the last class. Now, formula for the electric field will be represented by symbol E. Again, we will take the absolute value to calculate the number, and then direction we will try and find out using the diagram. And the formula will be KQ1 divided by R square. Now, in the case of fields, and forces, shall I say, there were two charges, so charge 1 and charge 2. So A and B, these were the two charges given to me, and we were trying to find out how much is the force of attraction between them, or how much is the force of repulsion. If they are like charges, so there will be repulsion, and if they are unlike charges, there is force of attraction between them. Now, when we try and calculate the electric field, we will only use the one charge. So if, let's say, this is a charge given to me, this is a positive charge, and I'm trying to find the electric field at this particular point. So electric field at this particular point, I'll take the distance from the charge and then use the amount of the charge. So the amount of the charge will be given to you in the coulomb. Let's say if it is 2.10 times 10 raised to power negative 3 or negative 6. So you will use that value here, and the distance will also be given to you, and you will feed that distance value down here, and then you will be able to find the electric field value. Now, there are a couple of things we need to know about the electric field lines. So if I draw a positive charge, for a positive charge, electric field lines are always represented outwards. So that's how electric field lines are. So if I wanted to find the direction for this electric field, this formula will give me the magnitude, and I'm trying to find the direction. It will be always away from the center or away from the sphere. And then if it is a negative charge, then it will be towards the sphere. So if this is like this, then electric field lines will be towards the sphere. And another thing which we need to know about the electric field lines is that electric field lines never intersect each other. So if this is a positive charge and this is a negative charge, electric field lines will move outward from the positive charge and inward towards the negative charge. That's how they will be represented. But electric field lines will never ever intersect each other. So you will never find electric field line which goes like this. It's crossing and crossing again. That will never happen. Electric field lines never cross each other. So these are the couple of things which we need to know before we start the math problems on electric field. So now I'm going to jump into a basic math problem on the electric field. So let's say we are given a negative charge. This is a negative charge given to me, and the magnitude of the charge is 2.10 times 10 raised to the power negative 6 coulomb. That's what is being given to me. And I were to find out the electric field value at a distance of well, it is, well, the distance is not given to me. So I will try and assume it. It is at a distance of, let's say, 1 meter. Let's keep the question relatively easy. So then I will, how can I find out? I'll try and use the formula electric field, which is equal to KQ1 divided by R square, and K value same as previous 9.00 times 10 raised to the power 9 multiplied by charge amount, which is 2.10 times 10 raised to the power negative 6, and the distance is 1 meter. So I will place 1 and then square it, and then whatever the multiplication of these two numbers will be, that will be the electric field value you will get. So if I do the calculation on my calculator, the value will come out to be 9 times 2.10, 18.9 times 10 raised to the power 3, and I can convert it into scientific form, 1.89 times 10 raised to the power 4, and the unit of electric field will be Newton per coulomb. That will be the unit, and I'll show you how we can drive the units for electric field. Now, if I see the force formula one more time, force formula was KQ1 Q2 divided by R square. This is the formula we did. Now, if I divide this formula with the Q2, or Q1, whatever the charge, one of the charge if I divide it with, and if I'm going to do the same thing here, then it's going to give me what? It's going to give me KQ1 divided by R square, which is equal to electric field, isn't it? That's the formula which we wrote initially when we started the electric field, KQ1 divided by R square. So now if I were to drive the units, the unit will be, the unit of force is Newton and the unit of charge is Coulomb. So Newton per Coulomb are the unit of electric field. So electric field has now another formula, that is force upon charge, force divided by charge. And the first formula was, which we've learned, KQ1 divided by R square. So these are the two formulas which we can use. Depending upon what's given to us, we will use the formula. So for example, if we are given that there are two charges, if there is a negative charge, another negative charge here, and then the force of repulsion between these two charges is something. Let's say it is given to me 5.6 times 10 raised to power negative 2 Newton, and I were to find out the electric field from the source, and then the charge quantity of this one is given to me. This is 2.10 times 10 raised to power negative 6 coulomb, and for this one I'm trying to find the electric field. So electric field value will be force divided by charge. In this case I cannot use the formula E equal to KQ1 divided by R square. Again, mark my words, I'm trying to find the electric field for this particular charge, and no distance is given to me, just a force of repulsion between these two charges is given to me, that is 5.6 times 10 to the negative 2. So I have to use this formula when the force is given. If the charge amount is given and the distance from where you're trying to find the electric field, that is given, then you will use the second formula. So hopefully that makes sense to you guys. Now, the next question I'm going to take, it will be similar to what we've done in the forces. So let's say if there are two charges given to me, one positive charge, another positive charge, and I were to ask to find out the electric field right in the middle of these two charges, and the distance between these two charges given to me is is 3.30 times 10 raised to the power negative 2 meter. That's the distance given to me. And the first charge is 1.5 times 10 raised to the power negative 6 coulomb. And then the second charge is 2.00 times 10 raised to the power negative 6 coulomb. That's what's given to me. And at this point, what is the net electric field? So again, electric field, because of this positive charge, electric field lines will be outwards. So they will move like this. And for this one also, they will be outwards. So both are in the opposite direction. So net electric field we can calculate by subtracting the electric field caused by A and electric field caused by B. So EA value will be equal to KQ divided by R square. Now that will be 9.00 times 10 raised to the power 9 multiplied by Q value, which is equal to 1.5 times 10 raised to the power negative 6 divided by R square. The distance is right in the middle, so that will be 1.65 times 10 raised to the power negative 2. I'm just taking half of this distance and then square it, and you will get the magnitude as 4.953 times 10 raised to the power 7 Newton per Coulomb. And this is towards the right hand side. And then we will try and find out EB also. EB value will be equal to, again, KQ2, I'll mark this one as QA, here I'll mark it as QB, divided by R square. So 9.00 times 10 raised to the power 9, QB value is 2.00 times 10 raised to the power negative 6, divided by R, which is the distance from the sphere B, which will be equal to 3.30 times 10 raised to the power uh, well, negative 2, and then we have to half it, which will be pretty much exactly same as, shall I say, the previous one. and then square it. This will be equal to 6.1. So I'm going to do the calculation. This value is 6.604 times 10 raised to power 7 Newton per Coulomb. Again, if someone doesn't know how to do the calculation, make sure you put everything in the bracket. Start with the bracket, use this term, then multiply with this term, and then you can divide by whatever this value is. So 1.65 times 10 raised to power negative 2, and then square it, and then you will get the right result. Now we got both the values EA and EB, and I have to find out the net E. E net, that'll be equal to EA, EA, which is towards the right, so this will be positive, plus EB. Right now I'm going to write just an addition. Later on I'll put the signs. This is towards the left hand side. So towards the right, I'll keep it as positive 4.9, 4.953 times 10 raised to the power 7, and this will be plus minus of 6.604 times 10 to the power of 7. Now the net value will be 1.65 times 10 raised to the power 7 Newton per Coulomb, and this will be towards the left because this value is bigger in size. So hopefully you got an idea of what the electric field is, and I'll see you with another video. Till then, goodbye.